Hey everybody, welcome back to the gamma function series. Today we're going to be proving 1 factorial. And we all know it's 1, but we're going to use the gamma function to verify it because the gamma function was made to generalize the factorial to more than just integers and to make it include negative numbers, imaginary numbers, all that good stuff. So yeah, it's there. I explained all that last time. But basically, we're going to be proving that 1 factorial is 1. We're going to be verifying that the gamma function does apply like it's supposed to, which, we know it does. But for the sake of this video, I want to show you to you why it does. So let's start. So 1 factorial, I don't want to do the whole gamma of something because it's kind of confusing with the n plus 1s and minus 1s. So I'm just going to go straight to the integral. So essentially, let me just go on this side. We have that 1 factorial is equal to the integral of x to the first power, because we're doing the first factorial, times e to the negative x dx. And that's really it. We can get rid of that 1 because, it's the point. And this is just an easy integration by parts problem. We don't even have to go through much. So, yeah, let me actually just use my other marker for our little UV stuff. So we get u being equal to something du, our dv, and our v. So we're going to put in a u and a dv. So what makes sense here? Well, if we take the integral of x, that's going to make something complicated. If we take the derivative of x, we're just going to get a 1 there. Let me actually make a better 1 there. It's just going to be 1, so it's going to make things easy. E to the negative x will then be this, and our integral of that is negative e to the negative x. Very easy. That's just a little u sub right there. Okay, and actually, before we continue, I should put in the limits. We're going from 0 to infinity. Should not forget about the limits. But yeah, so we're going from 0 to infinity, so this is going to be a definite integral. We can continue by putting in these things. So integration by parts formula, uv minus v du, and it's actually this integral here. So uv, so it's going to be negative x, so equals negative x times e to the negative x minus the integral 0 to infinity of v du. So v times du is just 1. This negative we can put in front, that negative and that negative will become a positive, e to the negative x dx. Alright, and you can actually notice, before we continue, this is just 0 factorial, which is what we did last episode, and we know that this is 1. So this is just 1, so I can actually put 0 factorial equals 1. Okay, well, what's this part? Well, we can't leave it like that. We have to put the bounds of integration, and they go from 0 to infinity. And you're like, infinity, we have an x there, an x there, it's really not that hard, because look, the negative exponent can turn into a positive, so we can do this negative x over, or we can, do it that way. And this is from, let me just give me some more space, again, from 0 to infinity. And it's like, okay, well, infinity, how is that going to work? Because look, if I do this negative infinity over e to the infinity, which one, how is this going to work? And it's actually really easy. Actually, let me just finish up this 0 over e to the 0, because when you plug it in. This is actually easy because the e to the infinity term will dominate over the infinity, because it grows at a faster rate. Exponentials always grow faster than linear terms. So if this is going to have a larger denominator, number overall is going to be smaller, going to approach 0 as we go to infinity. So, and then of course we have to remember the plus 1, which we found up here. So this is going to cancel out to 0. The negative doesn't really matter. This turns into a positive because minus minus. 0 over e to the 0 is 1, so 0 over that is just going to be 0, so 0 plus 0 plus 1, and we end up at our desired result of 1. So really, the reason why 0 factorial is equal to 1 factorial is because of this portion right here. this allows us to actually get something. This just is 0. But this, basically, 1 factorial is just that. Since this goes to 0, it just boils down to this. Which is really interesting, because that is exactly 0 factorial. That's what we found in the last episode. And so yeah, we just use integration by parts to figure this out. We could continue doing this with x squared for 2 factorial, x cubed for 3 factorial, etc. But that's, that's easy. We already know the answers to those. In the future, I'll be doing like e factorial, pi factorial, I factorial, square root of 2 factorial, all that good stuff. But yeah, so that's pretty much it. So hopefully you enjoyed, and I'll see you in the next episode. Bye guys.